Hello everyone, welcome to Reactive Labs. Today we are going to talk about another system design concept which is called Debezium. It's spelled as Debezium. Okay, so it's called Debezium. Hmm? And if we have to see on a high level what Debezium does. So basically, let's say you have a system. Hmm? Let's say you have a system called WhatsApp or Instagram. Hmm? So Instagram is collecting a lot of data. Hmm? And it's sending this data to their database. Okay, maybe SQL or some kind of no SQL, anything can be there, right? So, and then this database, you cannot store this only in the database, right? All the data, because you have to do some kind of analytics also. Hmm? So you have to send this data to your analytics engine, maybe let's say Google Cloud Platform, GCP. Hmm? So you have to send this data to this place, and that might go through some kind of service. Hmm? Some kind of service which will extract the data, extract the changes, actually changes, because you don't always need the data. Let's say one time you got the contents from the database, the entire thing. So from the next time, only the changes, only the additions or the deletions that are done to the database, only those need to be captured, right? So that's why I said extract the changes. Okay, and send to uh, analytics, whatever the analytics platform is, right? So now the question is, how does this happen? How will this data travel from this database to this service? Okay, and from this service to this, we don't care about this one right now. So we are only caring about how this happens. So basically this is called CDC. CDC means change data capture. Let's say you have this service S1. How does this S1 capture the changes which happens in this database, right? So for that we use Debezium. Okay, so this is where Debezium comes in. Debezium is an open source distributed platform which specializes in change data capture. Okay, so now that we know why we are studying Debezium, right? Because if it was not for Debezium, the process of doing the CDC, change data capture, would be very complicated. It would be very complicated. You have to write stored procedures, or you have to write some kind of functions which would do the, so you have to do a lot of manual work, right? And as I've mentioned before also, you don't always need to reinvent the wheel. If something is already there, try to use that. Okay, so that's what Debezium is. We will use Debezium for this change data capture. Okay, so that's why we are going to study Debezium. Hmm? So yeah, now that the why is clear, let's focus on what and how. Hmm? So the structure that we are going to follow today is, first we will talk about the brief introduction of Debezium. Next we will move to talk about its architecture. After that we will see the features. Next we will go into technical details. After that we will see the examples of where Debezium is used, then advantages and the challenges that come with Debezium. So yeah, let's start with the introduction first. So Debezium is an open source distributed platform. So it's an open source distributed platform for CDC, for change data capture. It's an open source distributed platform for change data capture. So it captures changes from databases, in real time. And streams them to various data stores and messaging systems. To various data stores and messaging systems. Okay, this allows you to keep data in sync across systems and build reactive and data driven applications. So as I mentioned, it captures changes from databases. So as I told you here also, changes in the databases will be captured. It captures changes from databases in real time and streams them to various data stores. For here, the data store is some kind of analytics engine, right? So it will stream those data, change data from the database to those services. Okay. So this was the introduction. Next, move to the architecture. Architecture. So first step is CDC. So CDC refers to the process of capturing and tracking changes. Changes like inserts, updates, deletes in a database. Debezium monitors databases and extracts these changes, streaming them to other systems. Debezium uses connectors that interface with database systems to capture change events and stream them to downstream systems. Next thing comes is Debezium connectors. Debezium connectors. So connectors are specific to different databases and handle the extraction of change data. Each connector is designed to work with a particular database. For example, for MySQL, the connector will be different. For Postgres, connector will be different. For MongoDB, connector will be different, right? And connectors are deployed as part of Debezium service, often running in a Kafka Connect cluster. So what is Kafka Connect? So what is Kafka Connect? So Debezium runs on Kafka Connect, which provides the infrastructure for running and managing connectors. Kafka Connect handles the distribution and scaling of data ingestion tasks. Connectors are configured through Kafka Connect's configuration files or APIs, specifying how to connect to the secure source database and where to stream the data. Also, actually, let me give you a fun fact about Debezium. So what's its pronunciation, or how is it named? How did they come up with this name, Debezium? So basically, if you remember in chemistry, usually when they ran out of names for the elements, let's say elements which are after 100 or starting from 100, it's like, let's say for one, I think they use for it's something like this, right? Something and ends with em, right? So that's the em here. So again, in this, while naming, they did like it will end with em and it takes something from the database, right? So database is basically db and databases is dbs. So it's basically Debezium, right? That's why it's read as Debezium and written as this, because they do not want to write it like this, because nobody writes it like this, right? Debezium. This will be very weird in looking and writing also. So that's why they wrote it like this. But the reason behind naming it Debezium was this combination of DBs and EM from chemistry. So yeah, when I got to know about this, it sounded fun to me. I hope it sounds fun to you as well. So now let's move to the features of Debezium. Features. First one is real-time data streaming. Real-time data streaming. So first is event capture basically. So Debezium captures changes from the source database in real time. This allows for near instantaneous updates to be streamed to downstream systems. And changes are captured as events with metadata, such as the type of change, like is it an insert or update or delete, and the data before and after the change and timestamp information. Next is support for multiple databases. Support for multiple databases. So Debezium supports various databases including MySQL, Postgres, SQL Server, Oracle, and NoSQL databases also like MongoDB. And we can build our own custom connectors for databases which are not natively supported by Debezium. Let's say, for example, if Cassandra is not natively supported, we can create our own connector and Debezium will work with that as well. Okay. Next is schema evolution. Schema evolution. So Debezium captures the schema changes, like new columns are added, changes in data types from the source database. This ensures that downstream systems are aware of schema updates. And the captured events include schema metadata, allowing customers to interpret the data accurately. Okay. And next is integration with Kafka ecosystem. Integration with Kafka ecosystem. So changes are streamed to Kafka topics, which can be consumed by various applications and data stores. Kafka streams or other processing frameworks can be used to process and transform the data in real time. Okay. Next, let's see the technical details. So the technical details include, first, database specific protocols. Database, sorry. Database specific protocols. So first one is log based CDC. Log based change data capture. Most Debezium connectors use log based CDC, which what it does is which reads changes from database transaction logs, right? This method captures all changes without impacting database performance. And next is polling based CDC. Polling based CDC. So some connectors use polling based methods to periodically query the database for changes. This is less efficient but can be used for databases that don't support log based CDC. Next is connector configuration. Connector configuration. So configuring a connector involves specifying connection details such as database URL, username, password, and other database specific properties. We can configure how changes are captured, including filters for specific tables or columns and options for handling historical data. And next is data formats. So change events are usually formatted in JSON, containing fields like operation type, table name, primary key, and before and after values of the changed data. Okay. And events include timestamps indicating when the change occurred, which helps in maintaining accurate event ordering and synchronization. Okay, let's talk about some of the examples. So examples as in, let's say we have to send our data from MySQL database to Elasticsearch. I have made a video on Elasticsearch as well. If you have not watched it, please go and watch it. Then you will understand why Elasticsearch better. So basically, it's a database, and if you have to search anything in the database, let's say your database has things like Apple, Orange, and if you just search for like let's say APLE, you will not be able to find in the database, right? But Elasticsearch has that capability. It can help you do that. And also if you search for something like let's say this database has billion records, and if you even search for Apple, this will take a lot of time, which is not the case of Elasticsearch. Why? Because I have explained this in my Elasticsearch video, Elasticsearch, and I think there is something about Elasticsearch index as well. Search indexes, yes. There are two videos. Please go and watch that. It will be very clear to you why Elasticsearch is fast and why do we use Elasticsearch and how Elasticsearch makes it possible to make the query faster. Okay. So yes, if we have to send the data from MySQL to Elasticsearch, what happens is first we have to do setup, and setup means first one in the setup, first we will do Debezium connector. Debezium connector. So we configure the MySQL connector to capture changes from specific tables. Next comes Kafka topics. So database changes, data changes, not database, data changes which are captured are published to Kafka topics, and then Elasticsearch sync connector. Elasticsearch sync connector. So use an Elasticsearch sync connector to index the changes into Elasticsearch. So the outcome is Elasticsearch indexes are updated in real time as changes occur in MySQL, which enables powerful search and analytics capabilities. So as soon as the change comes in this database, Debezium, what it does is it will just capture the changes and send to this Elasticsearch, which will make the query faster. So as soon as the write happened here, it's available here, right? So that was it. Another example, let's say, is Postgres to data warehouse. Postgres is another SQL database. Postgres to data warehouse. And why to data warehouse? I have another video on data warehousing specifically. So if you have not watched that, please go and watch it as well. You will understand the importance of data warehousing. So again, Debezium connector will come into play. So we will configure the Postgres connector to capture changes from relevant tables in the Postgres. Then changes are published to Kafka topics, and we will use a custom ETL, extract, transform, load process, or sync connector to ingest data from Kafka topics into the data warehouse. The data warehouse is continuously updated with real-time changes from Postgres, which supports up-to-date reporting and analytics. Okay, so this will be the outcome of it. Next, what are the advantages? Advantages of Debezium. So first step is real-time data capture. Real-time data capture. So it provides real-time updates of database changes, enabling timely data processing and synchronization. As I told you, as soon as the change happened to MySQL, Debezium collected it and sent it to Elasticsearch, right? So it happens in almost real time, near real time. Next is scalability. So it is integrated with Kafka Connect and Kafka, allowing for scalable and fault tolerant data streaming and schema handling. It captures and propagates schema changes, ensuring downstream systems stay synchronized with the source database. And what are the challenges associated with Debezium? First is its complex configuration. Setting up and configuring connectors can be complex, especially for large or diverse database environments. Next is resource usage. CDC, change data capture, can consume significant resources, especially for high throughput databases, requiring careful management of database performance and connector resources. And next is compatibility. Some database may not support the required log-based change data capture features, which necessitates alternative approaches or custom solutions. So yeah, that's all there was about Debezium. Basically, the point of this video was, what happens is sometimes when people are asked to draw a system design of, let's say, Instagram, so they will say that, okay, there will be a phone where people will use, there will be server, then let's say user registration happens or user does something, and that is captured in this database. Okay, and they say, okay, then there will be server is connected to some kind of analytics engine also, and server will be connected to some kind of, let's say, Elasticsearch also, but they never say how the data from this database will reach this Elasticsearch, how the data from this database will reach this analytics engine. Maybe some people do this, that okay, there will be another server which will take this data from here to here to here. So what exactly is this? How does this work? So I don't think, I have not seen anybody explain this thing, right? You have to go into the details here if you have to show that yes, you know this. Sometimes, because maybe at very entry level you don't need it, but as you become a senior, you need to know how this happens, right? So this kind of intricate level details makes you apart from other candidates or from other junior developers, which makes you look like, yes, you actually know about the system you are talking. So yeah, this is it. Debezium plays a very important role there when you have to take the data from the, because ultimately, not ultimately, primarily every data is stored in some kind of database, either a SQL or a NoSQL. But ultimately every data needs to go to some kind of analytics engine, because if it is a distributed system, they need to continuously upgrade their analysis, they need to continuously upgrade their analytics engine, they need to continuously upgrade their Elasticsearch, so that if, let's say, somebody has written something and somebody else comes in search of that thing, they should get it instantly. So Elasticsearch and analytics are very important part of any big distributed system, right? So that's why this Debezium is important, and it plays a really important role in some in those kinds of change data capture related events. Okay, so I hope you have a good clarity now on how change data capture change data capture happens, and how the changes propagate from your database to the streaming services or analytics engine or the Elasticsearch. Okay, so yeah, if you like the video, please hit the like button, and if you could let me in comments, I would really appreciate that. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.